Hello students, let us continue with our discussion on DFT properties. Today I will discuss about complex conjugate property. Complex conjugate property, that is third one. Complex conjugate property. Now, what exactly is this property? According to this property, if you are having a real valued sequence x of n, let us consider x of n, which is real value or real. Real means what? X of n is like 1, 2, 3 like this. It is real. There is no complex terms in this. It is simple real valued sequence. In that case, it follows complex conjugate property. Whatever x of k you are finding now, it follows complex conjugate property. According to complex conjugate property, x of k is equal to x conjugate of n minus k. That's what is the property says. According to complex conjugate property, x of k is equal to x conjugate of n minus k. If x of n is real, x of n should be real. That's what is the property. Now let us prove this property. Proof. Let us consider DFT of x of n. That is, x of k is equal to summation n is equal to 0 to n minus 1 x of n wn raised to kn, wn raised to kn, isn't it? Now let us apply conjugate throughout. Apply conjugate on both sides. Both sides. That means x conjugate of k is equal to summation n is equal to 0 to n minus 1 x conjugate of n wn raised to kn is there. No, this becomes minus kn because this is e raised to minus j 2 pi by n kn. That minus becomes minus plus, hence it becomes minus kn. But x of n is real, hence this x of n is real, isn't it? X conjugate of n is nothing but x of n. It is nothing but x of n. Hence, how I can write this? X conjugate of k is equal to summation n is equal to 0 to n minus 1 x of n wn raised to minus k. Why I replaced x conjugate of n with x of n? Because x conjugate of x of n is real. Real means what? 1, 2, 3. There are no j terms. Hence it is x conjugate of n is directly equal to x of n. Now this is. Now let us take one factor here. Consider wn raised to n into n. What is this value? You know that wn means e raised to minus j 2 pi by n. Okay? Multiplied by n into n. This n cancels. It becomes e raised to minus j 2 pi by e raised to minus j 2 pi n. What exactly e raised to minus j 2 pi n? E raised to minus j 2 pi by 2 pi n is nothing but cos 2 pi minus j sin 2 pi. This value is nothing but 1. Correct? The value is nothing but 1. That means I am simply, if I multiply here with 1, instead of that I can replace it with wn raised to n into n. Correct? Hence what I do? I just consider a factor wn raised to n into n here instead of 1. Right? Hence x conjugate of k is equal to summation n is equal to 0 to n minus 1 x of n wn raised to minus kn wn raised to n into n. Okay, n into n. Now why I made this n into n? Because it is simply a replacement for 1, that's all. Nothing changed as such. I just taken instead of 1 wn raised to n into n. Now this can be taken as summation n is equal to 0 to n minus 1 x of n wn raised to k n minus k into n, correct? N minus k into n, right? Now you see here, originally I had everything same, but here instead of wn raised to kn there is n minus k. Hence I can say that this, in terms of its complexity, I can just take this term as x of n minus k, x of n minus k. Again apply conjugate on above. What you get? If I apply conjugate of conjugate cancels out, x of k becomes equal to x conjugate of n minus k. That's what is the property says. X of k is equal to x conjugate of n minus k. The meaning here is it follows midpoint symmetry, conjugate symmetry. Let us consider n is equal to 8. Okay, in n is equal to 8 there are 8 points, isn't it? Here this n is equal to 8, x of k or DFT is symmetric about n by 2. What is n by 2? 4. That means it is symmetric about n by 2. Now there is 8 points are there, correct? 0, 1, 2, 3, 4, 5, 6, 7. It is symmetric about 0.4. It is symmetric about n by 2 or 0.4. That means x3 is equal to x5. x2 is equal to x6. Similarly, x1 is equal to x7 with the conjugate symmetry. Equal in the sense conjugate symmetry is followed. Conjugate symmetry is followed. Similarly, n is equal to 7. Suppose n is equal to 7. What is the midpoint? 3.5. n by 2. That is symmetric about 3.5. See this. 0, 1, 2, 3, 4, 5, 6. Correct? 6. Because it is 7-point DFT. Now midpoint is this, n by 2 point. Now x3 is conjugate of x4. x2 is conjugate of x5. x1 is conjugate of x6. x1 is conjugate of x6. This is what is happening. Obvious, here you can apply this formula also. For example, if you want to apply this formula, what is x6? x6, suppose you are taking 7 point, n is equal to 7, okay? x6 you want to find out. What is x6 point? X conjugate of 7 minus 6. That means it is nothing but x conjugate of 1. x6 is x conjugate of 1. That's what is the meaning. The example which I am solving in the next board will clarify everything to you. Let me solve an example regarding complex conjugate property. Okay, complex conjugate property. Try to understand that x1 is conjugate of x7, x2 is conjugate of x6, x3 is conjugate of x5 with respect to midpoint. Similarly, the same properties followed here. It is very evident from the formula. Let me take the formula and solve an example for you in the next board. Okay, let us solve this example. Example says that the first 5 points of 8-point DFT are given below. Find the remaining 3 points. Now the first 5 points are given and it's an 8-point DFT. Here n is equal to 8. Let us note that n is equal to 8. Next 5 points are given here. First x0 is equal to 0.25. Now x1 is equal to 0.5 minus j 0.5. x2 is equal to 0 and x3 is equal to 0.5 minus j 0.86. x4 is equal to 0. Now what about x5? x5 I can find using the complex conjugate property. What the complex conjugate property says, x of k is equal to x conjugate of n minus k. I have to use this property. That is also called a symmetry property. Let us see, x of 5 is equal to x conjugate of n. N means 8 minus 5. That is x conjugate of 3. What is x of 3? It is 0.5 minus j 6. No, conjugate of that. 0.5 plus j 0.86. Correct? That's what is x5. Now what about x6? x6 is conjugate of x2. Conjugate of x2. Anyway, I will write as a formula. X conjugate of 8 minus 6, which is x conjugate of 2. But x of 2 is 0. There is no meaning for that. X of 6 is 0. What about x7? x7 is 8 minus 7. That means x1 of x conjugate of 1. But anyway, I will write as a formula x conjugate of 8 minus 7. That is x conjugate of 1, which is nothing but 0.5 minus j 0.5 is there, no? Plus j 0.5. Hence, I found all the values. You are asked to find x5. x5 value is this, x6 value is this, x7 value is this. Hence, I am applying the complex conjugate property or symmetry property, symmetric about the midpoint, symmetric about the midpoint. Okay, now let us symmetric about this. That means x3 and x5 are conjugate. Okay, similarly x2 and x6 are conjugate, like that. Now I am just giving an assignment here. Try to solve this assignment. Assignment 7. You are given with 5-point DFT. In a 5-point DFT, first 3 points are given. First 3 points are given. They are like this. That is 3.5 plus j 0.364 and then 0.5 plus j 1.538. First 3 points are given. Find rest 2 points. Okay, use symmetry property. And it's a simple work. You have to find that. Okay, post me this assignment. It's a one-step answer actually. Anyway, go through this complex conjugate property. Very important. Okay, question papers are carrying very similar kind of example to solve. First 5 points will be given, or first few points will be given. Rest points you have to find out using complex conjugate property or this symmetry property. Thank you.